The Brain Tumour Charity provides a number of funding opportunities to researchers and even some support to them, such as through their Future Leaders programme. One future leader making waves is Veronica Rendo. She's working from Boston, so I packed my bags and got the next flight. I'm a student. I can't afford anything more than a 2-hour flight. So instead, I set up a Zoom call and thought this would be a good opportunity to include a young ambassador and friend of mine, Victoria.
Hello, Victoria. How are you?
I'm good, thank you. How are you doing?
Yeah, I'm all right. Bit stressed. Being a PhD student, that's life. Why did you get involved with the Brain Tumour Charity?
My dad had a brain tumour that metastasized from his kidney cancer he has. This was in 2017, December time. And then unfortunately by January, we actually lost him to some complications after brain tumour surgery. I got really interested in hearing people who had parents or family members or themselves had brain tumours. And I started realizing as many of us say, for a rare disease, it's really common. Once you've heard about it, you hear so many other people who have had experience of it. And then I saw the little application for Brain Tumour Charity Young Ambassador. And just last year, I thought, I feel ready. Why not try get involved with them?
Veronica's in the lobby, so I will let her in. Hi, Veronica.
Hi, Hannah. Hi, Victoria. Nice to meet you both.
So you kind of went into cancer research, specifically in Sweden. Was there a reason personally or a reason you were more interested in brain tumor research?
From a scientific standpoint, it was always really interesting in a way that compared to other diseases where there has been a significant advance for treatments and cures, we're still lagging behind.
And I guess have you found that applying for the Future Leaders grant has helped you?
Absolutely. Throughout the process, you had the opportunity of sending your research plan to patients. And that has a huge value because the actual target population has a voice in saying this is relevant or this is not. And it allows you to reshape, how you think about the project and really come up with questions that really matter, that really have a direct clinical impact.
Does your kind of research or your project have specific aims?
So this project is stemming from the fact that up to date, there are no clinically successful targeted therapies. And if you look at which genetic processes become deregulated in brain tumors, the p53 signaling. p53 is a major protein in the context of cancer. It's been studied for decades and it's known as the guardian of the genome because basically what it does is that it acts as a sensor of stress for the cell. And cancer cells that just want to continue dividing no matter what, you would imagine that they want to get rid of this protein. This is the biology that we are focusing on the project. Something that is really fascinating is that if you look across different tumor types, for example, ovarian cancer, breast cancer, you'll find that many patients in their tumors have inactivated this p53 protein through some mechanism. But in brain tumors, this protein is still functional. And instead, what happens is that cells come up with other mechanisms to bring those levels of the protein down. But that creates a unique opportunity because if we can come up with ways to release what's making this p53 come down and we can have it again in its active form, then we potentially can restore those stress sensing signals that could tell the cancer cells, hey, there's a lot of stress here, you need to die.
Wow.
Yeah,
That's really
it was really incredible actually.
Well, I'm really excited to keep an eye out on your research, Veronica, and yours, Hannah, to see how it all develops in the next while.
Thanks so much.
Yeah, thank you for joining us, because I know the time difference can be a bit tricky to figure out.
Please help fund the brightest minds in brain tumour research by donating to thebiggive.org.uk. For 1 week only, your donation will be doubled. That's double the funding for research and double the brain power.